Today's lesson is on inverses of linear functions. By the end of today's lesson, you should be able to find the inverse of a function given its equation or its graph. And this is a continuation from a previous lesson. Recall that functions have inverses that are also functions if they are one-to-one. With the exception of horizontal lines, all linear functions are one-to-one and thus have inverses that are also functions. In this lesson, we will investigate these inverses and how to find their equations. Exercise 1. On the grid below, the linear function y equals 2x minus 4 is graphed along with the line y equals x. How can you quickly tell that y equals 2x minus 4 is a one-to-one function? Well, remember, one-to-one function, for it to be a function, it has to pass the vertical line test. In order for it to be a one-to-one function, it also has to pass the horizontal line test. So it has to pass both the vertical and the horizontal line test. And that line, 2x minus 4, does. So, in part B, it says graph the inverse on the same grid. Recall that this is easily done by switching the x and the y coordinates of the original line. Since it's easy to switch the coordinates, I'm going to make some. So this is my function, f of x. I'm going to call this one f of x. So one of our points is 2, 0. Another point is 3, 2. And another point is 4, 4. So that means the inverse, which I will do in red, f to the negative 1 of x is going to be 0, 2, 4. So I took the y line and put it in x, and put the x line in y. So 0, 2, 2, 3, and 4, 4. And then connect your dots. I'm always crooked, sorry. Like when I write on this. And this is f to the negative 1 of x. Now, remember this line is the line of reflection, or the symmetry line. So you can tell that those two graphs are symmetrical to the highlighted line. So what can be said about the graphs y equals 2x minus 4 and its inverse with respect to y equals x? So it's a reflection, or y equals x is symmetrical. Which means if I folded the paper on that line, those graphs would be on top of each other. So now, of course, you need to find this equation. Well, think about what this said. Switch the x and the y coordinates. So if I have the equation y equals 2x minus 4, we had to switch the x and the y coordinates. So this becomes x, and this becomes y. Well, we need it to be in y equals form, or slope-intercept. So how do I get y alone? How do I undo subtract 4? I add 4. How do I undo multiply by 2? I divide by 2. And there's my equation, which was my answer to part E. So you have to do 2 steps. The first step is to switch x and y coordinates. The second step is to get y alone, or into y equals mx plus b form. Okay? So that's how you find the inverse of a line, or the equation of the line. As we can see from part E in exercise 1, inverses of linear functions include the inverse operations of the original function, but in reverse order. And that was how we undid and got y alone. So inverse of linear functions include the inverse operations of the original but in reverse order. So you're going to simply switch x and y in the original equation and solve for y. So that's huge. So although this is simple enough procedure, certain problems can lead to common errors when solving for y. Care should be taken with each algebraic step. So they want us to find the inverse of the linear function y equals 2/3 x plus 8. So the first thing we're going to do is switch x and y. Then we are going to undo or inverse the operations. So we have to move that 8 first. We always want to undo, add or subtract first. So we're going to subtract 8. So x minus 8 equals 2/3 y. Now how are we going to undo 2/3 times y? So we could divide by 2/3, but that gets tricky as we get into advanced math. There's a better way to undo that fraction, and that's to multiply by the reciprocal. So we're going to multiply by 3/2. So that we have to do the same thing on the other side, multiply by 3/2. So what does y equal? We have to distribute this, so 3/2 x minus, and I would either do this math quickly in your head or use your calculator, 3/2 times -8, which is -12. So our answer to this question is choice 2. The best way to undo fractions is to multiply by the reciprocal, because that's what dividing by the fraction does. Okay? Dividing by a fraction is the same as multiplying by the reciprocal. Sometimes we are asked to work with linear functions in their point-slope form. The method of finding the inverse and plotting it, though, do not change just because the linear equation is written in a different form. Remember, as soon as you see inverse of a linear function, you want to switch x and y and get y alone. So, exercise 3. Which of the following would be an equation of the inverse y plus 6 equals 4 times x minus 2? Switch x and y. So x plus 6 equals 4 times y minus 2. Is that answer there? Nope. So we have to do some math. So x plus 6 equals 4y minus 8. Now we're going to notice these all have y alone. Ooh. So let's put 8 back over. So x plus 14 equals 4y. Then we have to divide by 4, so y equals 1/4 x plus 14 divided by 4. So we know that the answer can't be 3 and can't be 4 because they don't have a slope of 1/4. So now what I want to do is probably simplify these choices and see which one gives me the same answer. So the only difference in these is one of them has a negative slope and one has a positive. Well, it's not number 2 then, because it's not a negative slope, so my answer is number 1. A way I could check myself, add 2 to the other side, plug that into my graph, plug this into my graph, and you'll see they're the same line. If you want to do that tomorrow in class, just ask. Exercise 4. Which of the following points lies on the graph of the inverse of y minus 8 equals 5 times x plus 2. Explain your choice. So we know, because this is in point-slope form, we know that the slope is 5 and the point, which is x1 comma y1, is x is here. So be careful because this says plus 2. We know it's a -2. And then this one is a -8, so it's a +8. Because the equation, remember, is y minus y1 equals m times x minus x1. And that negative sign or minus sign means opposite. So here's our coordinate, x, y. So inverse means to do what to x and y? Switch x and y. So it becomes inverse is 8 -2. Choice 1. So there's a couple tricks there. Be careful. Signs matter a lot in math. So it says explain your choice. So that means we have to use words. So we could say the point in original equation is -2, 8. Inverse, switch x and y. So 8, -2. It doesn't have to be a giant paragraph. It just has to explain the steps in the math that you did. So exercise 5, which of the following linear functions would not have an inverse that is also a function? Explain how you made your choice. So think about what we highlighted on the previous page. It was in the middle of the page and it said, no, it was at the top of the page. With the exception of horizontal lines, all linear functions are one-to-one and thus have inverses that are also functions. So which one here is a horizontal line? So this is not, so y equals 2 does not have an inverse because the equation would be x equals 2, which is a vertical line that is not a function. Terrible handwriting, sorry. So explain means you need to write in words. Justify means you have to show work. So we know that y equals 2. Its inverse is not a function because its inverse would be x equals 2. That's a vertical line, and a vertical line is not a function because it does not pass the vertical line test. Good luck with this. If you have questions, make sure you answer or ask them in class.